Sup, bro? End of mission.
Hey, bro.
We're here to talk about Ultimate Ragers on Mars, man, bro. I'm Paul, the pressure-fed bro. And who are you, man?
Yo, bro, I'm Face of Sarcasm. Just happy to be here. Came here for some of the cold brewskis. This is going to be great.
Yeah, that's what we're doing. We're going to Mars again. On Mars Observer.
Again?
Yeah, going to Mars again. Mars Observer. This one's pretty important, bro.
Heck yeah, brother.
Okay, I'm gonna stop with that because it's gonna get weird. But yeah.
Okay.
So hi everyone. End of mission. We talk about space missions that have ended. This one's gonna end pretty interestingly. Spoiler alert. We've talked about it.
Yeah, I was gonna say. I feel like we spoiled it already with Mars Global Surveyor.
We've spoiled this so many times. It's like we're finally here. This is the prequel that no one wants.
We finally made it to the Phantom Menace.
Finally! Yeah! Now this, bro, is pod racing.
Oh gosh.
Okay, so Mars, the party planet. A lot of parties in the 60s and 70s, right?
Yep.
Big spate of exploration. NASA even lands spacecraft on the surface.
Ooh, exciting.
Right?
You get to see all the rocks and the cold brews.
Yeah, look at this place. Rager. Best kegger ever had, right?
Yeah.
Now, of course, they're powered by RTGs, which means they will eventually die.
Eventually.
So, it's November 11th, 1982, okay?
Okay.
When did Animal House come out?
I have no idea.
That was before Blues Brothers. That's like late 70s. So it's like that. So this is Chrysae Planitia. That's what we're looking at here in this picture. And we're on
Heck
Viking.
yeah.
And this party is called Viking 1. Now, the RTG's kind of starting to fail. But NASA has rewritten the charging code in the computer so that it charges differently to stretch out the lifespan of this equipment.
Okay. All right.
Now, unfortunately, this script also has an error in it that tells the antenna to stop pointing at Earth.
That's a great move. That's a bold strategy, Cotton.
And thus ends the initial bout of Mars exploration.
R.A.P. Viking 1. We salute you.
Yep. Now, early 1980s, NASA has now become more of a bureaucracy, right? It stopped being the one-shot hero program like the Apollo program, all that big stuff. Now it's kind of become a bureaucracy, right? You got the space shuttle. You're probably focusing more on getting a more institutionalized system.
Yeah.
And
yeah.
they
trying to... Sorry.
Speaking. I want you to speak more. You didn't speak much last time.
Okay.
He's gonna be quiet the rest of the episode, isn't he?
No. I'm not gonna be quiet the rest of the episode.
Yeah. Okay. So NASA's they've got the big missions out, right? You got the Mars landings, you got the Voyagers, they're outgoing. You're building Galileo. NASA now wants to start focusing on successors to this. This is called the Planetary Observer Program. Have you ever heard of that?
I've never heard of that. This is completely new to me.
Yeah, I know, right? So the idea was you're going to continue on with NASA's space exploration successes, but you're going to make it more useful and practical so you don't end up with multi-billion-dollar spacecraft that don't need to be.
But I want to have multi-billion-dollar spacecraft that needs enormous amounts of research and development for.
Oh, well, I have a spacecraft for you. It's called the James Webb Telescope, okay?
Yay!
James Webb was like initially designed in the late 90s with a 2008 launch on the shuttle.
Oh, man.
But it was delayed a little bit. And it cost a lot more, but it's returned a lot of really good scientific data. So who's to say?
Worth it.
But so implementing this program and this new mindset going into the future, you have 3 things you need to do. 1, maximum design inheritance. So use spare hardware, use commercial satellite buses, maybe even build a modular bus. Kind of like with Solar Maximum. Right? Modular bus, that sort of thing. Controlled scientific scope. Pick a
We're
mission.
going to do a whole lot. We're going to just do everything with the one mission. Yes.
Yeah, that's a great way to make things work, get them done on time and under budget.
Yep.
And number 3, this one's very important. Avoid technical changes. A good example of this, Galileo switching a launch vehicle and its trajectory to Jupiter.
I'm sure the tape will be fine.
Yeah. And thus, Planetary Observer was born early 1980s, and they had a few ideas of what they were going to do. So there are several missions planned in 1984 from a certain paper I read that discusses, future observer and planetary missions that are going to take place. The first one is Venus Radar Mapper, also known as Magellan, which we're covering.
Ooh, yeah. I was going to make the same joke, and you steamrolled it.
I steamrolled you. Yeah. Look,
you steamrolled
me.
Look,
Mao.
Mao? What?
Yep.
When did space get so political?
I don't know. We're also launching PAM. Hey! Send Mars Geoscience / Climatology Orbiter. This would become Mars Observer, which we're talking about today, and sort of Mars Climate Orbiter. Oops. Then we have Comet Rendezvous Asteroid Flyby, CRAF, which became Near Shoemaker pretty much. And then there's Titan Probe Radar Mapper, which would evolve into Saturn Titan Orbiter and Probe, also known as Cassini.
Yeah, Cassini.
That's a good mission. I've started doing some work on that one for the end of next year.
Yeah.
Then I have Lunar Geoscience Orbiter, also known as Lunar Observer, which famously launched and mapped out the moon for mid-90s Return to the Moon.
Mm-hmm.
That obviously happened.
Yep, definitely. I remember.
Then we have Near Earth Asteroid Rendezvous, which is like the grandfather of what would actually fly. The idea was there, and then it, thanks to another certain important mission that we're talking about, become what it actually became.
Got it. Okay.
Venus Atmospheric Probe. That never happened. Mars Surface Probe. That also never happened. Then Comet Intercept Sample Return, which that's a cool mission idea. That didn't happen either. There've been plans for it, though. There were plans to send another probe to the one that Rosetta went to take samples and come back. Yeah. There are a few studies around that. Yeah. And it's just, you do the math, you start working out, what can we do in our budget? What's of scientific interest today? Kind of like how a bunch of new discovery missions were baselined for Venus, thanks to the phosphine discovery, even though phosphine isn't there anymore.
They lost it?
Well, it turned out to be a false reading. I think that's what happened, but it was something like that. Yeah.
Don't you love making multi-million-dollar bets on false readings?
Yes. Now, these missions are supposed to cost $100 to about $200 million in 1980, which is about $320 to about $700 million today. So a nice pretty penny. With an annual,
pretty cheap.
Yeah, I mean, relatively speaking, with an annual expenditure rate of about $60 million a year. So this would be like support staff, engineering staff. You got to have the Deep Space Network, that sort of thing.
Right. So basically like $700 million to launch it and then $60 million to just keep it running.
Yeah, it's like with the Chandra X-ray telescope. Was it X-ray? Right, that one's up there. And it was going to be canned, or it's going to be canned in a few years because it just costs a lot to operate. People have been trying to save it.
Okay.
Now, the missions would be baselined for launch on low-cost upper stages, PAM, IUS, Transfer Orbit Stage, and size to be no greater than half of the Space Shuttle payload bay. They're still going to launch them out of the shuttle.
Nice. Okay.
Mars Observer, the first one, is actually baselined for STS-64 in 1988, and that's an actual picture of it.
Oh, cool.
Yeah, it was supposed to be in the shuttle. It didn't happen.
That's a diagram of how it was supposed to be in there.
Yeah, and STS-64 does fly. It's like a space lab mission, so it's not that exciting. I mean, science.
Boring.
It's a mid-90s science mission. Wow.
I wonder if they're going to grow protein crystals on it.
I'm going to make the bet that they're going to do that on that flight. So, Mars Observer is interesting because it's the first NASA probe built out of a commercial spacecraft bus.
Ooh, interesting. Exciting.
Yep. This is the RCA AS-4000 bus. It's also used for the Defense Satellite, I think, monitoring platform, DSMP 50-2, and then TIROS, which are weather satellites.
Very exciting.
Oh,
Very exciting.
And it weighs about 2.5 metric tons, about 5,700 pounds. The payload mass, the scientific equipment, is about 156 kilograms, or about 350 pounds. That's about my weight, isn't it?
Somewhere around there. I think a little lighter.
I'm a bit lighter than that. The propellant is about 1.3 metric tons, or about 3,000 pounds of propellant in there. Getting into orbit around Mars takes a lot of effort.
Yeah, so it's mostly just the propellant to get you around there. Okay.
Yeah. And it has 172.5 megabytes of memory storage on its tapes.
Out of curiosity, how big... depending on how long this episode goes, my audio file is going to be larger than that.
It's like the audio for this, like this video itself is about 3 to 4 gigabytes in size, and it's HD YouTube. Like after all the editing and all that, it's about 4 gigabytes.
Yeah, it's not a whole lot. Memory tape's doing a lot of heavy lifting.
Yeah, it's a VHS tape player again. So this is a rough diagram of the spacecraft here. It's an older version of it. You can tell because the solar array is different. You're just going to be quiet now?
You cut out. I'm sorry.
Oh, where did I cut out?
You can tell that the solar array is older because...
It's different.
Because of the way it is.
Yep. So this is, of course, the diagram of the actual spacecraft as it was built.
Cool.
Yep.
Just kind of he's got a big stick, got the umbrella.
Yep. It's a space probe. There's not many shapes they can take.
This one's going to be a box.
Wow. So there are 6 main goals for Mars Observer. Identify and map surface elements and features. Wow. Measure the surface topography and features. Wow. Exciting.
Cool.
Define globally the gravitational field.
Yeah.
Determine the nature of the magnetic field. Is it good? Is it bad? You know, what is it like?
What is its nature?
Yeah. Determine the distribution, abundance, sources, and destinations of volatile material. That's carbon dioxide, water, and so on. And dust, the most important thing ever, over a seasonal cycle.
Yes, you need to count every single speck of dust.
And there's see all that dust down there? You are. Of course, my pen is the same color as there's dust down there. You can see, I'm pointing at it.
Yeah.
And then explore the structure and aspects of the circulation of the atmosphere. Because Mars has an atmosphere.
I thought Mars was flat. Is it supposed to be flat?
Parts of it are. Feels like
so
it.
Why are you saying the circulation? It's flat.
Oh, I'd say flatulation, but that's a different thing.
Yeah, it's sneaking in a little bit of methane in there, right?
Yeah. Look, it's the funniest rager ever. It's late at night. You're to start saying weird things. Weird things are going to be funny, okay? We're both slushed. We've been talking about random things for 3 hours. Big party, okay? Mars.
Big party. Mars.
So the mission design itself is to put Mars Observer in a sun-synchronous orbit so that when it goes over the day side, it's roughly 2 p.m., and it's 2 a.m. on the night side.
Interesting. Fascinating. This is entirely new information to me.
Yeah, don't worry. This is not important. This mission isn't really that important. So roughly it's gonna return 120 megabytes per day, which again is like the size of the audio file you're gonna send me for this episode. And it's gonna send 80 to 90 gigabytes in total during the 687-day mapping mission. To put this into perspective, all of the raw video I made for designing a better OTRAG was about 83 gigabytes.
Also, to give this thing credit, this is 80s technology and 80s memory.
Yes, it
80
is.
to 90 gigabytes is like 2/3 of all of the digital storage that is available at the time.
Yeah. It is like Yeah, they had just requisitioning VHS tapes from other people's houses. Like, we need this for the mission. Come on. And of course,
that's why they needed to switch over to DVD.
Yeah, and of course, at that point, it'd be Laserdisc.
Oh yeah,
yeah. And 687 days, of course, is a full Martian year.
Yes, because it's like 1.88 Earth years.
Yeah, and so you can see it's going to arrive in the northern summer, right, roughly. And so it's going to enter northern fall. It's going to see the big dust storms because it's going to be southern spring when that's when they have the sublimation to cause, the massive dust storms. And it's going to see a full seasonal cycle. Don't look at that. That's okay. That doesn't happen. All right. So to do these 6 main goals of observing Mars, you have 8 pieces of equipment, technically. And so this is the spacecraft, as you can see. Right? You got a magnetometer. Whoa.
Yeah. Wow.
Yeah.
Exciting. Never seen one of those on a space probe before.
Oh, never. Solar panels. So yeah, get a good look at all that. So we'll look at every equipment because I found pictures of them.
Good.
So we have the gamma ray spectrometer, which is going to characterize
It's going to find the Hulk.
It's going to find the Hulk on the surface of Mars. I bet he throws a good party.
You have to. He has to. It's big and green.
Yeah. I mean, what else do you need to have a party?
I mean, he'd drink kegs like they're regular beers.
See, that's the secret, Tony. I'm always partying. So what it's really looking for is water on the surface, because during the Viking missions, they found frost.
So, wait, why would you use a gamma ray spectrometer to find water?
Because gamma rays are gonna hit the surface and it'll come back up.
Okay.
And you can carry and because emission spectra, that's how you can find it. That's what the gamma ray thing can do. I guess it's good at that. I'm not a scientist. I'm an engineer. We're going to spend some time talking about the propulsion system. I know about propulsion systems. Okay, we're going to talk about that. Okay.
Okay. So I imagine that the water has to be at the very least like highly visible at the gamma ray spectrum. Yeah. Because otherwise, why would you use a gamma ray spectrometer, right?
Yeah. Or they're specifically looking for water or hydrates to find water.
Or it is just looking for the Hulk.
Or it's looking for the Hulk, and he knows where the water is. We sent him out to get some ice. He hasn't come back yet. We got to find him, bro.
Yeah.
Then we have the Mars Observer Camera. It's a high-resolution camera, where at the closest, its resolution is 240 meters, or about 790 feet per pixel.
Wow, never seen this image before.
Nope, it's definitely not going to be important later. Then we have the Thermal Emission Spectrometer. It's looking at the infrared thermal emissions from the atmosphere and surface. Again, you're characterizing the surface of Mars. What is it like? What's where? What gets hot? What doesn't?
Right. Yes, and it's also a spectrometer, so looking at what it's made of.
Yeah, what
rocks taste like.
Yeah, what do rocks taste like?
Tastes great, bro.
Yeah, it's great. I dare you to eat that rock, bro.
Bet.
So we have the pressure modulator infrared radiometer. So this is going to look at the horizon of Mars and look at the vertical profile of the atmosphere.
Ooh, okay.
Right, because the atmosphere...
So it's gonna see the different rainbow bands of...
Yeah, well, it's because as you go higher, right, the thermal profile might shape like this. Like Earth has one that's not like that, but the temperature changes as you go. And you want to characterize that, because then you can figure out what's the structure of the atmosphere, what's it made of, and because if you want to land something on Mars, you need to know what the atmosphere is like.
Yeah, but also, haven't they already landed something on Mars at this point?
They want to land more things, like people.
Oh, okay. Yeah, no, that helps.
And then you have the Mars Observer Laser Altimeter. They're going to measure
Wow.
Yeah, I wonder what that does.
Yeah. I've never seen this image before.
You've never seen that one before. And it does radio science with, I guess, a microwave, because it's got an oven. It's the Doppler stuff to measure gravity.
Yeah,
that's
you see, like you get the radio transmissions. You measure. You see Doppler. One of them gets more red. One of them's more blue, and then that allows you to see, like, hey, this one's being slightly accelerated more.
Yeah, and the changes you can measure. Yeah, you got some crystal, man. This is gonna be a very interesting party at some point.
I put the crystal in the microwave. I put the crystal in the microwave, and it measures the gravity.
Yeah, I put this crystal in the microwave. It measures gravity. Don't ask me how this works.
Want to see the oscilloscope?
Yeah, that's pretty cool. Then we have the magnetometer and electron reflectometer. It's looking for the magnetic field of Mars.
If there is one, right?
That's true, if there is a magnetic field around Mars. And then there's the Mars balloon relay. So the French actually wanted to put something on Mars and land it with a balloon.
Kind of like what they did with Venus?
Kind of like Venus, yeah. And you kind of recognize a bit of this, too. It looks kind of like how the Spirit and Opportunity landed on Mars, like the big balloon to land. And this would have been an antenna to relay between it. Because a lot of the Mars orbiters now are also relays for the rovers. Yeah. So Mars 94 did not happen. I don't know why, but it didn't happen.
Interesting.
There was also a Mars 96, which is supposed to land on the surface, and I think it exploded. Or it didn't leave low Earth orbit. It was a Russian mission if you hadn't figured it out yet.
Never would have guessed.
So here are the 3 pictures of Mars Observer being built.
Cool.
Yeah. So
it's expensive.
How expensive do you think Mars Observer is?
80 million.
You are off by an order of magnitude.
800 million.
Yes. So you can see the different parts of it, right? It's all folded up. Yep. So it's sitting on the transfer orbit stage here.
Right.
There's a big antenna. It's all packed up for launch, not on the space shuttle. Yeah. Again, 3 pictures of this thing, and this one's the clearest, as you can tell. Ugh.
Well, they need to save all the memory for the mission, right?
Yeah, they got loaded. Yeah, they put the VHS tape in already, so you can't put any more pictures.
It's one of those crappy cameras that you had like in the 2000s, right? Where it's like you take the pictures and then you chuck it when you're done.
Yeah, disposable camera. Jeez.
Yeah.
Here, I just found So this is the diagnostic and checkout station for the spacecraft. I just saw a picture of this one. I'm putting this in the slides.
What the heck is this? This looks... I feel like the image is baked. Like it got irradiated somehow.
Yeah, they're testing out the gamma ray spectrometer by firing gamma rays at it. Yeah.
Look, either it doesn't work or you become the Hulk, all right? That's one of 2 options.
Yeah, and... Yeah, so this is the computer that they're using to make sure it works.
Wow, look at how advanced and high-tech that is.
Again, there is more memory being used to make this video than there is in this entire thing, probably.
Yeah.
All right. So it's baselined on STS-64, but everyone said, nah, the shuttle's kind of busy right now. Could you put on something else? And
the thing that they decided to do was Titan 3.
Yeah, the commercial Titan 3, which we last saw launching Intelsat 603 and breaking.
Cool.
Don't worry, this one worked.
Okay.
So you can see it's put on commercial Titan 3. They wired it right this time. Don't worry.
Good.
Yeah, so you can see it is baselined on there. I found these diagrams and I like them, okay?
Yeah, they're good diagrams. Very visual.
Yeah. And, okay. So I actually have a video of the launch. We'll do that. So the launch is on the 25th of September, 1992 at 17:05 UTC, which is, I think, 11 a.m. Eastern Time.
That sounds right.
Yep. So this is actually the last flight of the commercial Titan 3.
Really?
It only flew 4 times, yeah.
Wow.
Yeah, it cost too much for the market it was getting. It was trying to eat up Ariane 4 launches, but it cost too much.
Oof.
There's something. I think there was something else that was an issue with it that prevented it from being a successful commercial launcher. But yeah, it only flew 4 times, and this is the last time it did that.
Dang. R.I.P.
It's a good looking rocket, I'll say that.
Yeah.
I like Titan 3. It launches from LC-40 at Cape Canaveral. For those of you who follow the modern day, this is where SpaceX launches Falcon 9 from.
Cool. Exciting.
It is. It is exciting. And I have video of this. I think we're at about T-minus 60. Ooh, inertial guidance. It's only in one ear.
Side.
Yep. Really exciting. Budget cuts, you know?
One side.
Yep.
Only one audio channel.
Yeah.
A shark? Let's blow this candle.
Yeah. Look at that logo.
Heck yeah.
Yep, so that was the launch. And I actually have a button for the press from that launch. I'll edit it in here. Isn't that cool?
Good looking pin.
It's a good looking pin.
That's cool.
You have one too, right?
Yeah.
Yeah, because I got you one for Mars Global Surveyor.
Yeah.
Which I don't know what that is. Of course, we don't know what that is. Obviously.
We don't know what that is.
No.
Yeah.
So it launches LC-40, and it's no issues. It works great. Woohoo!
Yay!
And it's on a 1-year trajectory to go to Mars. And it's been the first mission to Mars since the Vikings landed in 1975.
Yeah, it's been a long time.
It's been a while. It's been about 11 years. Yeah,
something like that. Yeah.
So it launches on September 25th, 1992. It'll do orbit insertion on August 24th, 1993.
Heck yeah.
Right, goes into transfer orbit. It's basic orbital mechanics. This is not an orbital mechanics episode. I'm sorry if you like those.
Yeah.
So en route, it takes a handful of pictures. This is Jupiter taken on April 14th, 1993.
Huh.
Yeah.
Look at that.
Yep.
It's got some of the moons.
Possibly.
What do you mean possibly?
Look how defined Jupiter is. That could just be debris. I don't know.
What are you talking about? Have you? I've taken pictures of Jupiter and the moons with a telescope that I have. It's a cheap telescope.
That's true.
You can very clearly see the moons.
Okay.
So
it's probably that.
I'm gonna guess that'd be like Ganymede and Callisto, maybe.
Yeah, probably the outer
one
ones.
of those.
Yeah.
Yeah, because the inner ones would be a lot closer.
So then in July, so we're a month away from orbit insertion, it gets it gets an image of Mars here in black and white, and it gets a picture of Mars in color right here.
Whoops.
Like, man, that picture right there is like 100 megabytes of data for a VHS tape. Okay, it's pretty detailed.
Yeah.
Count
all the pixels on there. That's
all 3 of them.
Yeah.
I think it is like 4 pixels in size. That's the size of Mars in this picture.
It looks like it's 5 pixels.
Yeah. All right. So for the 24th, the orbital insertion here, right? You got to you got to pressurize the propulsion system, right? You have 1.3 tons of propellant. You got to pressurize that. It's a pressure-fed system. Now, it wasn't pressurized at any point until now because why do that?
Yeah, I mean, what are you going to do? Pressurize it halfway there? It's like, yep, it pressurizes.
Yeah, it's
cool.
So 3 days before orbital insertion, they'll pressurize the propulsion system, right? Just to make sure it works, right? It gives you time in case it doesn't, or in case, right, you might have an issue. Gives you time to do Mars orbit insertion. Now, the antennas use what's called a traveling wave tube. It makes antennas work. I'm not an electrical engineer because I'm normal, Dad.
Just calling them out like that.
Yeah. And so when you So the system's not pressurized. They have what's called pyro valves that prevent the helium from the high pressure tank going into the propulsion system. And the
Don't
ignition,
want to mix it there.
and the ignition of the pyro valves, since it's basically simple, it says bang, open, right?
Mm-hmm.
Well, the violence of the bang open might damage the traveling wave tubes. So before they pressurize and open up those valves, they turn off the traveling wave tubes, and they turn off the antenna and turn off telemetry for orbital insertion burn, right? For pressurizing the tanks for the orbital insertion burn. So
that's a great idea. Have it turn its phone off.
Yeah.
Set it to airplane mode.
Yes.
To then pressurize the tanks and then establish communication.
Yeah, I'm putting my phone into airplane mode to turn the car on. I don't know what's going on here. But hey, they turn it off at the right time. It's gonna pressurize and open up the valves, and they'll talk back about 20 minutes later.
Okay, so it's just a little blackout for 20 minutes.
So on August 21st, 1993, at 1 a.m. UTC, Mars Observer doesn't talk back. Please tell me you thought this slide was funny.
I did. Yes.
That's great. So for those of you who don't know, because I'm gonna be that guy. So this is from Drake and Josh. It's a TV show from the 2000s. And in the episode, they're making a treehouse for somebody, but Drake forgot to cut a hole in the door, and they have to leave. And Josh looks at Drake. Where's the door? Where's Mars Observer? So, an $816 million spacecraft just exploded.
It's a good use of money.
Now, in your engineering expertise, based on all of the evidence around you, what do you think went wrong?
My estimation is that, it was clearly during pressurization, right?
Yeah, that's actually pretty easy to figure out. It's the one thing that's happening on this mission.
Pressurize the tank and we'll pressurize a little too much, right?
It's actually different. This is actually pretty interesting. So this is a diagram of the propulsion system for Mars Observer.
Beautiful.
So you can see there's
work of art.
So there's 4 big engines. You got 4 little small trim engines, and you got the big propellant tanks, right? NTO, MMH. Hypergolic system based off a satellite bus, right?
Mm-hmm. Yep.
Now, in simple terms, this is what I was telling you about earlier, right? So you have a high-pressure helium tank.
Mm-hmm.
You got lines here to 2 separate pyro valves, PV7, PV8, goes through a regulator. And then you got 2 pyro valves here, because, right, you have NTO and MMH, right? These are our hypergolic propellants, right?
Okay.
So it goes in and would pressurize them. So what are these?
CV.
So these are
I don't know.
These are pyro valves. These are check valves.
Oh, yep. CV check valve. That makes sense.
Right. So pretty much what a check valve does is it makes sure if something's going through it, if it goes this way, only stuff goes that way through it.
Okay. So it's only one direction. Got it.
It's one direction. Yes. What happened and what was discovered was they corroded during the year-long transfer from NTO.
Oh my gosh.
So if you look here on the left, I have drawn you, myself, as the screen after 1 month exposure, and it looks nice and healthy, right? But if you look at it after a year, you see it's all corroded.
Yeah.
So what happens if it corrodes? NTO vapor works its way into the pressurization system. So guess what happens when you open up the pyro valves?
Lights the whole thing up.
Right. You open up the pyro valves, the helium pushes the NTO through here, and probably some MMH made it in too, because it's been a year, right? And they explode in the propellant lines. Right, so the propulsion system blows itself up. It vents all that helium out, and it's under the foam and not the foam, the mylar and insulation. So it starts tumbling, right? And it goes, right, so it starts tumbling. That's not good. But it goes into a safe mode that doesn't tell Earth because the antenna's off. Yeah.
Love material science.
Yeah.
Hey, if we put this check valve into place, is it going to corrode over time? Nah, it'll be fine.
So you can read the report for this. It's linked in the description of, what exactly happened. Now, we don't know 100% what happened because, again, there is no telemetry. It was off. We don't know.
Yeah.
But, so there's 12 general concerns they find in the investigation on a system level. On the component level, it's way worse. I was going to say that. There's stuff like, they're talking like, the way you installed the capacitors could have caused a short circuit to kill the vehicle, that kind of thing.
Oh.
Yeah. So, observation 1, the telemetry should have been on. I think that's important.
Really? You don't say.
Yeah. The top level systems engineering was inadequate. This is the kind of the, what systems engineering is, right?
This is where you engineer systems.
Well, it's systems engineering is taking something big and complex like a full spacecraft and breaking it down into components that are more manageable. And then when you build them, you make sure they work together.
Right.
That's systems engineering, right? It's making sure that when you put your units into your spacecraft, it's the right ones. That kind of thing. So at the top level, it just wasn't right. It allowed for a lot of bad things to go through. So the contract philosophy was inappropriate after 1987 and didn't use JPL properly. Now, I didn't get into this. I didn't read any of the contract or what that specifically meant, but I guess the way they approached building and operating Mars Observer was wrong, and they didn't use JPL properly, which that would help. They've been to Mars before.
Here's how you don't accidentally blow up your spacecraft.
The overall software development was unsound. They can't code good.
What? In the 80s they couldn't code no good?
I guess not. There's like one programming language. I don't know. I don't know. There was far too much reliance on heritage for hardware, software, and procedures. So, for example, those check valves were designed for a geostationary satellite. Well, geostationary satellites do their main burns about 8 hours after launch, not a year.
That makes a lot of sense. So you don't really care if you couldn't really find out if they corroded or not because you'd never check them.
Yeah, because you'd never use them until you do a graveyard maneuver and it just blows up and whatever. Who cares?
It's like, oops.
This is a good one. Several inappropriate trade-offs were made between redundancy and weight. So if I recall specifically, the report says there's like 6 pounds of stuff you could have added to prevent this from happening that you got rid of. Like in the propulsion system. Yeah. And this is a big problem just with spaceflight in general is, okay, do you add the extra redundancy for, one contingency, or do you put the really cool science experiment on it?
I'd rather put the really cool science experiments on there if I was making those decisions.
And then, of course, you explode over Mars.
Yes. No science for you.
Yeah. Spacecraft autonomy was overly relied on, but not understood or tested. Again,
that's weird. I feel like they made a movie in the around this time that talked about kind of automated systems and whatnot.
Yeah, weird. Inadequate testing of some systems, so that big computer bank we showed you didn't work all the way, I guess.
Look, we can either wait another 16 hours for it to tell us that everything's fine, or we could just send it.
Yeah, let's launch it. Come on, I want to go party, man. Let's go. God.
Yeah, come on.
The Hulk probably found some ice by now, at least. Jeez.
Yeah.
The program did not have the flexibility to accommodate externally driven changes. That kind of ties in with systems engineering, where they couldn't change things, I guess.
Yeah, you can't adapt to changing circumstances. It's like, well, guess I'll die.
Yep. Oops. Yeah, I'll start drilling holes in the propellant tanks. Yeah, whatever. Who cares? Look, I looked at the microwave in the oven, and it told me to do that. The crystal microwave oven, and it told me to do this. God, I can't speak. So then we have no risk management plan to make system-wide trade-offs between competing requirements. This is very systems engineering based, right? Because you think, because with like doing trade-offs, right? Well, we got to change the solar array. How does that impact your thermal management, your electrical system, right? That sort of thing. It's like when you fly internationally, you need a plug adapter to make sure you have the right one. It's like that. They didn't do that. Yeah. There was, let's see, not testing the traveling wave tubes in the transmitter power amplifiers for shock induced by pyro valves was a mistake.
Not making sure that it worked was a mistake.
You don't say.
Does this work? Yeah, probably.
We hope. I hope. We'll know. We'll know if it doesn't.
Yeah, the spacecraft will tell us if it doesn't.
Yeah. There's too much reliance on preloaded software scripts for long command sequences that were not necessary or appropriate.
Look, every single time we get rid of this one line, the whole system crashes. All right, we had to keep it in there.
Yeah, it's really weird. I don't know why. Pretty much right after this happened, NASA said, yeah, we were doing Mars exploration wrong. Let's completely restructure the whole program.
You know what? That's good. That's good.
Yeah.
We're learning the lessons, right?
Yeah, we shouldn't have not done that. That was a dumb idea. That was a bad party. I should have studied for that test. You know?
Yeah, bro. Look, I'm a little too hungover. I was making all these decisions after I had a couple of cold brewskis. It was not good.
Not good at all. So they call this, the new program, the Mars Exploration Program, which is still going on to this day.
Heck yeah.
Now, Mars Observer, obviously you couldn't make Mars Observer again. You had to make it in the aggregate, right?
Mm.
So we have Mars Global Surveyor, which we saw last year.
Yeah.
Yeah, Mars Climate Orbiter, which didn't work.
R.I.P.
The Gamma Ray Spectrometer is on 2001 Mars Odyssey, as you can see.
Ooh, yeah.
Yeah, which that is the oldest active spacecraft around Mars right now, by the way.
It's still going?
It's still going, assuming the budget cuts don't go through. And then we have the Mars Reconnaissance Orbiter, which is the second oldest thing orbiting Mars.
Heck yeah.
Yeah. So far, the Mars Exploration Program has sent 15 spacecraft to Mars and the surface. This includes rovers, of which 2 have failed. Cough. Cough. 5 of these spacecraft are actually currently operational, including Mars rovers.
Okay.
Yeah. And that's Mars Observer.
Nice. Great work, guys.
Excellent work, lads. A space mission that failed so badly, you had to rebuild Mars exploration because of it. That is honestly, that is jeez.
I'm glad that they did change the way that they approached it, though, because otherwise you'd just be getting Mars Observer every mission.
Yeah, we just keep sending out Mars observers. They keep exploding. And I told my friend about this, and he said, "It's like, yeah, it just sounds like you're feeding spacecraft to Mars." And I started crying. It's another meme I'm referencing. I probably referenced it badly, but yeah,
I don't know.
It's fine. It just seems like you're just feeding Mars probes to Mars. It just keeps like you're doing that. But yeah, Mars Observer, the mission that failed hilariously. I think it's funny.
It's really funny.
You turned off the antenna and then it exploded. We think.
It's like, okay, radio side. Yeah. We'll talk to you again in like 20 minutes. Oh yeah, yep. No problems, no worries. 20 minutes goes by, 40, 60, and then oh no, it's gone.
Where's Mars Observer?
Drake, where's Mars Observer? Like imagine you're talking to somebody. It's like, hey, Discord keeps messing up. I'll cut it out, and then 20 minutes later, I'll come back on, and we can keep going on. And then the person drops, and you never hear from them again.
Yeah. It is so interesting. And this isn't the only time a historical propulsion system has blown up a spacecraft, also.
Really? You don't say.
I think Landsat 6 exploded because of its pyrazine feed lines, also.
I mean, if there is anything that's going to explode in the spacecraft, I would assume it would be the propulsion system.
It'd be pretty weird if something else exploded.
Yeah, it's weird. This the radio antenna, the dish, that exploded.
Boom! I don't know. Yeah.
Made by Michael Bay. Oh, okay.
Yeah, it's made of explodium. That's a systems engineering failure right there.
Yeah.
But hey, we finally did it. We've talked about this mission for what, 2 years now?
Yes, and now we finally talked about it.
We finally did it.
Yeah.
And on the next episode, we're going to do STS-30 and die in the Philippines.
Woo! I'm excited.
The other mission we just talked about today, Magellan.
Yeah.
That'll be fun.
I'm doing that one.
Yeah, you are. It's going to be your first shuttle mission. And
I hope...
What?
Sorry?
I was going to make a joke about how
Go
you're
ahead.
doing the rest of them this year.
Oh, yeah, that is true. Yeah, that is right. That is right. I hope it goes well. I hope it goes well with me doing STS-30. We don't know yet.
Yeah. Nope, not at all.
Definitely haven't recorded that one before this one.
Nope. We don't. Yeah, we do everything in order. This is actually... When is this coming out? Like September 30th? It's actually...
September 29th.
Yeah, we're recording this. We're not doing anything ahead of schedule. We've never done this before. I say, having joked about IFT-10 exploding. The original IFT-10, before we recorded the one I just uploaded today, it's August 9th. Hey, that means this is the 20... What? No, not the 20... 30... God, I'm old. This is like the 32nd anniversary of this happening.
Happy birthday!
Happy Explosion Day!
Light off your fireworks in your house, in your hand.
Yeah, that's kind of how that happened, isn't it?
Yeah. Put your phone on airplane mode and then light up
and play with fireworks
in your hand. Smoke a joint? Wait a minute. This is a pipe bomb.
Yeah, this is the weirdest party I've ever been to. Yeah, no phones, everybody.
Yeah, the bouncer on Mars is kind of strict.
Yeah, he is very strict about that.
But good on him.
Good on him. Mars Observer. Fun mission. I do like discussing things exploding.
Yeah, it's really fun.
Yeah, we'll do Mars Climate Climate Orbiter eventually.
Climate Observer. Yeah. That's all it ever did.
At least they kept talking to that one when it died. Yeah. The whole Mars curse thing is pretty funny if we ever get to do something on that. Because those old Soviet missions are pretty funny.
That's the bouncer. That was the bouncer I was talking about. It's the Hulk on Mars.
Oh, yeah. Yeah, because Mars 3, their lander, I think it was Mars 3, the Mars lander landed, turned on, took a picture, and then died.
Photographer's dream.
Yeah. Yeah. Mars, we finally went back to the party planet for, like, a picture. We got a selfie with it.
Yeah.
We didn't actually go in. My friends, they're here. They're just not in the picture. Don't worry. They're here. We're having a really good time.
Yeah, they go to a different college.
Yeah.
You wouldn't know them.
Yeah, they're somewhere else.
Yeah.
I think that's everything.
Sounds like it.
Yep.
Well, thank you all, everyone. Thank you, everyone. Yeah, and thank you, everyone, for watching and listening and enjoying End of Mission. Please be sure to comment, like, share, subscribe, tell your friends about it incessantly. Divert every single conversation you have with them into discussions about End of Mission. And until next time, which you'll be seeing and hearing my face again, this has been End of Mission.